So let's take a look at these harder types of problems involving compositions. And because these are not the normal polynomial functions that you're used to working with. You have absolute values, you might have square roots or cube roots for these. Okay, but the process is exactly the same. So if we evaluate this j of g of -2, what this means is we're going to take j of, work our way from the inside out. So if we take our g function and substitute in a -2, so I'm going to come up here and evaluate g of -2. I get 8 times the absolute value of -2 minus 1 plus 10. If we continue to simplify, the absolute value of -3 is 3. 3 times 8 is 24 plus 10 gives me 34. So I'm going to come down, plug that in here. So I have j of 34. I'm going to evaluate that. So here I'm going to take my outer function. Everywhere there's an x, I'm going to replace with a 34, whatever's in my parentheses. Notice the -5 is outside of the radical. So I get the cube root of, here is 45. All right, I want you to try the next one here. G of f of -2, please. If you start from the inside out, f of -2, we take our original function, use the -2 in our placeholders. Okay, so everywhere there's an x, we're replacing it with a -2, and that's going to give us -11 times 4, minus a minus becomes plus 10 plus 8, and here we get -44 plus 10 is -34, plus 8 is -26. Okay, so there's my f of -2. And then I'm going to take my g function here. Oops. So I'm taking g of -26. And when I plug that in, I get 8 times -26 minus 1 plus 10, giving me -27. And when I evaluate that, if I multiply this through, absolute value of -27 is 27 times 8, 216 plus the 10 gives me 226. And that would be my solution. Okay, now, if you're using your TI-89s, did anybody set this up using the Y editor? Okay, so I'm going to show you how to do this because for most of them, it's okay, but when you get to certain radicals, the calculator is going to display it in a different form than what you enter it. But when you enter your answer here, you need to make sure you can convert back into whatever form they started with. So if they started with a radical form here, don't write your answer in rational powers. Okay, so let's say we used our calculator for this. We go into our Y editor, and we enter these three equations. So -11x squared minus 5x plus 8. So there's my f1. My f function is y1. Next, I have 8 times. Remember, absolute value is not the symbols here. We need to alpha lock and type the word ABS. That represents absolute value. X minus 1, close that off, plus 10. Notice it displays it in the way that you're expecting to see. And then the same thing is going to be true with your cube root. Now, I'm not sure. I don't think mine is going to display it correctly, but I'm going to type it in anyway. And then if I have to, I'll go back in and change it back. So if I start with the root, if I want to enter this as cube root, I'm going to type in root, and then inside, again, we don't write it the same way that the MyOpenMath is. The setup for the roots here is we take whatever the expression is inside the root first, so x plus 11, and then comma the index of our root, okay, and then all minus 5. Okay, so this is how you would enter it on yours. Okay, now, because this is an operating system that's a little bit older than what you guys have, it may not work. Okay, and so it didn't on yours. You should see it show up as the cube root. Okay, but what I'm going to have to do here is I'm going to have to change this back into the rational powers. If I was writing this as a rational power instead of the root form, I'm going to have to put it into the rational power form, which is the index of 3 gives me a rational power of 1/3. So x plus 11 to the 1/3 minus 5 is equivalent to this. Okay, now, even if you guys put root, your answer when you evaluate them is probably going to show up in the same form that mine does with the rational power. So we'll be able to talk about how to translate it. Okay, so here, let's do the bottom one first, g of f of -2 first. Okay, so if I want to confirm that it was 226, I take my g function, which is y2 of y1 of my value -2, close that off. And when I hit enter, it confirms 226. I did that one right. Okay, and then the second one, again, as I go through this, I take my j function, which is y3, of my g function, which is y2, of my input, which is -2. And when I hit enter, okay, so this is probably what your computers or your calculators displayed as well. Okay, so let's go in and take a look at how this translates back. Okay, so when you write your answer, notice that you have two different bases with the same rational power denominator of 3. Okay, so what the calculator displayed is 5 to the 1/3, 3 to the 2/3, and then minus 5. Okay? So if you combine these all into the same power of 1/3, well, the power of 1/3 is cube root. So this is like saying the cube root of 5 to the first times 3 squared. And what is 3 squared? 9. 9 times 5 is 45 minus the 5. So notice you get your solution here. When you rewrite it back into its radical form, instead of that rational power form. Okay? So if you are going to use your calculators, okay, you do need to be able to translate back and forth. If you're not going to use your calculators, it shouldn't matter. You'll be able to see it right here directly.